So I think we made a decision. We machined that down so we can actually drill the holes for the smaller bolt circle and tap it. So you can put studs in. Look, that's a bit smaller. So we can, there's enough meat here so we can actually turn it down a little bit just to make enough room for the bolts so they clear here, and then we drill the holes just 15 degrees offset from the other ones, put M6 studs in and then wedge the pulley in between. That was always my preferred idea. That's how we do it. So let's dial that in and turn it down. I need to check how much, but it's not much, probably 2 millimeters or so, just to clear the bolts so we can actually tap it. So we got it dialed in, 100 of a millimeter, half a thou, that's fine. We indicated that phase as well. It's a bit rough, so should be alright. And then we just check what the diameter is and machine it down. I wonder if this is actually cast iron. It machines like cast iron. It's very dusty and no chips. Yeah, it's certainly not hard on the insert. It just makes a funny noise. I didn't expect that this is cast iron. It machines like cast. I think it is cast. Yeah, I think it's cast iron. Doesn't produce chips. I thought it's steel, so that makes life easier. Yeah, it's not killing the insert, so it's not hard. Alright, it was a good idea because I was thinking about welding on one of these. That's probably a bad idea. Anyway, let's machine that down. So we're done. We are 88 millimeters. Gives us enough clearance for the bolts, and some flesh actually in the pulley itself. We skimmed it off a little bit. It was not wobbling. It was strange. It was not flat. I think it doesn't really matter if you clamp it on some steel, but in this case I just wanted to have it nice. Put the chamfer on, so everything is fine. Now we need to clean the machine because everything is full of cast iron dust. Alright, one done. Next one will be the pulley. So that's probably a bit challenging for the machine. It's an ER40 collet on an MT2 taper, and that drill is, I don't know, where's my caliper? It's 46 millimeters. I just want to get a big hole in there, and I don't know if we can make enough torque. It's aluminium, so it should be fine. We'll give it a try. I just had the idea because it's a reduced chunk, 1 inch, and I have a 1 inch collet here, so we'll see if it works. Obviously we're gonna go really slow. Kerosene, and then just see if it works for spins. It's taking some chips, rattles a bit, but probably can go a bit faster and get more torque. Now the draw spins in the chuck. That's what I was expecting. It's the shaft of the drill is rusty, and I think the grind of that drill is not very nice either. We'll see. Actually doing better now. because now the drill is centered in the hole, and we can make some nice chips here. Let me remove those chips first. It's actually doing well. I think the grind of that drill is not exactly good for aluminium, but it does drill. Kerosene and try a bit more speed. It's actually doing very well with high speed. Hitting that out diameter of the drill. It's getting me nasty now, but I think this grind doesn't cut very well. It does cut, but not very nice. Anyway, we get what we want because we want. Now we put a lot of heat in. That step here in the drill is not sharp. It's just hogging, basically just displacing material. I'm happy with the hole. We just go from the other side then. Yeah, saved me a lot of turning because this machine doesn't have a cross feed. So yeah, alright. Could it be worse? But ridiculous amount of chips. Anyway, yeah, now we have a start point because we need to make that 88 millimeters, and it's easier doing this way. And I wanted to try that chuck in that machine. It seems doing well. I just need to change. I need to work on my gearing. I need to make a back gear for that machine because the ratio is just not good for going low on the. You know, if you use a VFD, at the very bottom end there is no torque. The problem is the motor can't go much faster, so if I need high speed, that's the next problem. So I probably think about some back gearing. I thought for a while I could use a smaller motor pulley, but I don't have one, and it's just the motor has enough oomph, but it's just if you go low, it's only about 400 RPM or so on the motor, 300 maybe. It's just it doesn't have the power to do it. Yes, I could do it on the big light, but aluminium on the big, don't know. Anyway, we'll hook the rest out with a boring bar to 88 millimeter. That's the best we need, and then we just drill from the other side because we need to get there as well. We've done 88 millimeters. I didn't film that, and it's warm, so it has no play, and if it's cold it fits perfectly. So we are in 45, so we leave that hole as it is. We need 40 for clearance, or 41 for clearance. We turn it around and grip it on the inside here, and then machine the other side for the smaller one. So that fits perfect. We might need to machine something off this one here as well. We'll see where the bolt holes end. If they're too close, we just machine something off. Should be alright. Okay, let's turn it around. And this is a used pulley, but it's okay. And so we don't need the the fence here, because this is the fence. Alright. So we decided to hog it out the boring bar. The reason is I have something to indicate, because now it will be concentric to this outer diameter. I didn't trust that original pilot bore. I indicated on the pilot bore and it was not really in center. What I did, I put a belt on and was indicating on the belt, because I could see when I got on the teeth, I got one area where it was flat and the other one it was high. So I tried it a few times and it was probably about quarter of a millimeter out, that center hole. I don't know how good they are, because normally you clamp it on the boss and then you just bore it out. Yeah, so that was not really in center. Anyway, we don't care about the holes, we just leave them. Now we can turn it around and indicate it on the inside diameter, because that's perfectly in center to this one here. So the plan, before you need to get rid of these strips here, this aluminium is awful because you can't grab it with a magnet. So we clamped it the other way around. Interestingly, there is a bit of a recess here, and that was the boss was sticking out about 8 millimeters or so. That's where we clamped it before. Now we just grabbed it on the inside because that's a non-critical surface, so I can actually dent it if I want to. This one needs to go so, like so, and yeah, we just hog it out like we did on the other side. I'm thinking about checking the run out on this one. It's hard to do that. We'll see. The only way to indicate is actually put it on a shaft and run it and spin it and see how much run out it's got on that surface. But it should be that's a register surface, so it should be machined okay. Anyway, it's the reason why I used the used pulley is because of that. Just in case it doesn't work out, I didn't waste the new pulley. I have another one. If that works out, we use that, and if we see some issues with there's a groove here, but it should be okay. It doesn't take a lot of load. We only transferring probably 1.5 kilowatts there, maybe 2. Yeah, so we need to hog that material out, make that fit, then drill the holes, because this is the smaller bolt circle compared to the other one. We just sandwich it together and then just drill it with these as guides. That should be it. Anyway, it's pretty warm at the moment because I did some heavy cuts here. See some nice and curly chips. It's late dinner time. Carry on tomorrow. Thanks for watching. Thanks for subscribing. Until next time.